Welcome to the Explainer. Now, if you're tuned in, you're probably already pretty focused on understanding the actual mechanics of our changing planet. You know the usual suspects, right? Carbon emissions, deforestation, heavy industrial pollution. But today, we're looking past the surface. We're going to examine a recent breakthrough in climate science. It's a hidden multiplier that historically just wasn't fully accounted for in our models, but it is quietly and fundamentally accelerating the planet's most severe threats.
52. It might seem like just an innocuous, random number at first glance, but 52 is the terrifying ratio that currently defines our global environmental reality. And honestly, it's the key to understanding the sheer scale of the challenge we've got ahead of us.
So where exactly does this number come from? Well, in a massive breakthrough draft for the Proceedings of the National Academy of Sciences, researchers established a brand new scientific baseline, and this fundamentally shifts how we've historically modeled climate change. It reveals that our global pollutant burden currently exceeds the Earth's natural hydroxyl, or OH, cleaning flux by 52 times. Put simply, you've got 74.657 parts per million of pollutants pressing down against a measly 1.44288 parts per million of natural cleaning agents. This incredibly severe imbalance, that is what researchers are calling oxidative inundation.
So the crucial point to take away is this. Oxidative inundation is not some cinematic doomsday switch that just suddenly turns the planet's ecosystems off overnight. Rather, it's a cross-cutting stress multiplier. It doesn't magically pull new, unheard-of dangers out of thin air. Instead, it takes literally every existing life-relevant hazard we already face, everything from heat waves to ecosystem loss, and makes them significantly worse, way faster, and much, much harder to reverse.
Here's our roadmap for the Explainer today. 1. The hidden climate multiplier. 2. Surviving extreme heat stress. 3. Amplifying global warming thresholds. 4. Accelerating ecosystem collapse. And finally, 5. The danger to life dashboard.
All right, part 1, the hidden climate multiplier.
Okay, let's dive right into how this domino effect actually works. It all starts with step 1, a higher index of oxidative inundation. Basically, as we overwhelm the Earth's natural self-cleaning ability, we trigger step 2, the atmospheric lifetime of methane actually increases. Because there just isn't enough OH to break it down, this highly potent methane hangs around in the atmosphere much longer. This naturally leads us to step 3, which is a rise in background pollution, especially persistent, dangerous ozone. And finally, step 4, global warming accelerates. It's essentially this vicious feedback loop where pollution literally paralyzes the planet's ability to clean itself.
Part 2, surviving extreme heat stress.
Now, before we can grasp the full threat here, we have to clearly define wet bulb temperature. You know, standard thermometer readings? They don't tell the full story of heat danger. Wet bulb temperature is a measurement that combines both heat and humidity to figure out the actual survivability of those conditions for the human body. See, because we cool down primarily by sweating, if the air is too humid, our sweat simply cannot evaporate. Wet bulb tells us the exact physiological point in which our bodies literally lose the ability to cool down.
Looking at this wet bulb temperature matrix makes the danger incredibly clear. Notice how the relative humidity scaling up on the left interacts directly with the air temperature on the top. A wet bulb temperature of 35 degrees Celsius for several hours is highlighted for a very good reason. It's completely unsurvivable for human beings without active cooling, like air conditioning. Seriously, it doesn't matter how much water you drink or if you're sitting in the shade. At 35 degrees wet bulb, the human body just cannot shed heat, and your core temperature will rise to fatal levels. What should really grab your attention here is how this multiplier effect accelerates our trajectory straight toward these lethal limits. A wet bulb reading of 30 to 33 degrees already triggers mass casualty risk, especially for vulnerable populations. And at about 3 degrees of global warming, highly populated regions, we're talking South Asia, the Gulf states, parts of Africa, they're going to begin experiencing those 35-degree unsurvivable events. Because our oxidative inundation multiplier keeps methane around longer and drives extra warming, it's aggressively pushing these regions toward these lethal limits much, much faster than traditional baseline models ever predicted.
And this brilliantly illustrates the physiological reality behind all those abstract temperature data points. Notice the profound physical impact of heat stress on the human cardiovascular and nervous systems. Your heart is forced to work exponentially harder just to pump blood to the skin to try and cool you down, which can lead to a dangerous drop in blood pressure and an elevated risk of cardiac arrest. Meanwhile, the nervous system is facing severe stress, resulting in confusion, dizziness, even convulsions. We're not just talking about being uncomfortably hot, we are talking about systemic biological failure.
Moving on to part 3, amplifying global warming thresholds.
The math here is frankly pretty sobering.
In a world where we enact zero major climate interventions, baseline models project a warming of 3.5 to 4.5 degrees Celsius by the year 2100. But when you factor in this worsening oxidative inundation, that trajectory gets shoved closer to 4 to 5 degrees. The reason? That extended methane lifetime we discussed uniquely adds an extra 0.1 to 0.3 degrees of warming entirely on its own. This single, historically hidden multiplier practically guarantees we are pushed toward the absolute extremes of climate projections.
Part 4. Accelerating ecosystem collapse.
This severely bleached and dead coral structure is not some theoretical projection of a distant, dystopian future. It is the devastating reality of what relatively low levels of global warming are already doing to vital ecosystems under acute thermal stress right now.
When we map out the stark math of extinction, the gravity of the situation becomes absolutely undeniable. At just 1.5 to 2 degrees of global warming, we face a 90% loss of coral reefs. At 2 to 3 degrees, that loss hits 99%, accompanied by a high extinction risk for countless other species. And by the time we reach 3 to 4 degrees of warming, which is the exact accelerated trajectory our multiplier is pushing us toward, we're looking at practically guaranteed, widespread global species and ecosystem collapse.
Which brings us to Part 5, the Danger to Life Dashboard.
Let's see how all of these threats synchronize and build on one another. At our current 52x inundation level today, we're already seeing wet bulb temperatures cross 30 degrees, alongside baseline methane warming and accelerating coral decline. But as that multiplier scales to 60x, wet bulb events over 32 degrees become a regular thing, adding extra warming and widespread biome shifts. Hit 70x, and we reach regional lethal heat limits and the total collapse of sensitive ecosystems. And if we actually allow that multiplier to hit 80x, we trigger an era of global catastrophic heat, massive extra warming, and a full-scale global biodiversity crisis.
So, what's the big takeaway from this explainer? Oxidative inundation isn't just another data point for the history books. It ultimately represents the breakdown of the Earth's natural self-cleaning limits. We are actively paralyzing the planet's atmospheric immune system, and it is silently but forcefully magnifying every single other climate threat we face.
Which leaves us with this crucial, pretty heavy question to reflect on as we wrap up. If our planet has a hidden constraint on its ability to self-clean, a hard limit to what it can naturally wash away, how fast are we willing to push it to the breaking point? Thank you so much for joining me for this explainer, and as always, keep questioning the data.